Welcome to the MJIC 2026 Virtual Innovation Competition. I'm Arina from the Advanced Medical and Dental Institute, USM. This video highlights my lead-free radiation shielding innovation using micro-nano tungsten carbide and bismuth oxide polymer composites. Lead is widely used for radiation shielding because of its high density and atomic number, but its health and environmental risks drive the need for safer, lighter alternatives. Polymer composites with high Z fillers like tungsten carbide and bismuth oxide show strong potential as eco-friendly lead-free shielding materials. Its toxicity and weight cause major environmental and handling issues. We therefore design a safer, lighter, lead-free tungsten carbide bismuth oxide bricks and assess their X-ray and gamma shielding versus lead. Our method starts with preparing the composite using about 7% epoxy resin and 93% combined micro-tungsten carbide and nano-bismuth oxide fillers. The mixture is mechanically stirred, hand-blended under a fume hood, then poured into a custom silicone mold with a hexagonal interlocking design. Finally, the samples are cured at room temperature for 48 hours. For testing and characterization, X-ray shielding performance is measured using a digital radiography system at tube potentials between 40–120 kV at Agency Nuclear Malaysia. Gamma attenuation is further evaluated using a Canberra Genie 2000 multi-channel analyzer system with sealed sources covering energies from 60 to 1333 kV at UKM. Using the Beer-Lambert law, we assess radiation properties, compare our hexabricks to lead at various thicknesses, and determine the photon range where they perform most effectively. For the result and discussion, the radiation protection efficiency shows lead bricks still provide the strongest shielding across all thicknesses, especially when the thickness exceeds 3.5 cm, achieving more than 85% efficiency at high energies above 1173 kV. Our fabricated hexabricks show a consistent efficiency of around 80% across medium to high photon energies. While they outperform thin lead layers, their performance remains slightly lower than thicker lead bricks. For diagnostic X-ray energies, the hexabricks showed strong shielding, reaching over 2.6 lead equivalent thickness. They achieved 100% dose attenuation, confirming they can fully block diagnostic X-ray photons at protection levels comparable to several millimeters of lead. At 5 cm thick, the hexabrick is just 1.3 kg, less than half the weight of a lead brick. It matches the weight of 2.1 cm of lead, but outperforms it at high energies, making the shield both lighter and easier to handle. For both linear and mass attenuation coefficient, all samples show strong attenuation at low energies. As energy rises to about 662 kV, attenuation drops and lead bricks thicker than 4.2 cm start to outperform the hexabricks. At high energies, linear and mass attenuation coefficient fall for all samples, with the hexabricks providing weaker shielding than lead. While hexabricks show higher half and tenth value layer than lead, they still offer strong protection. At low energies, lead performs better, yet hexabricks achieve 99% RPE. At medium to high energies, they reach 80–98% RPE, close to 2.8 cm of lead. For the mean-free path, lead bricks between 0.7–2.1 cm show consistently lower at all energies, while the hexabricks have higher value, especially at high energies, indicating weaker attenuation compared to lead. These hexabricks have strong commercial potential. They can be made into interlocking bricks, wall panels, or protective barriers, are suitable for mass production via polymer casting or molding, and could expand into modular shielding systems, radiation-proof coatings, or custom 3D printed components. Benefits include safe handling, strong low-energy shielding performance, and a lightweight hexagonal interlocking design for easy installation. Our contributions include developing new micro-nano lead-free composites for radiation shielding, with applications in medical imaging, nuclear medicine, and portable barriers, strengthened by industry collaboration with chem biotechnology. Our hexabricks have been thoroughly tested and characterized at Agency Nuclear Malaysia, earning a certificate of shielding performance assessment that confirms their effectiveness. In addition, the hexabricks have been granted patent and copyright filing protection by MyIPO. In conclusion, hexabricks are lightweight, non-toxic, eco-friendly radiation shields, highly effective at low energies, outperform thin lead layers at high energies, but need greater thickness to fully match thick lead bricks.